Good morning. We are discussing the reactions of phenol. Last class we have discussed Reamer-Twain reaction and its mechanism. Now next is another reaction, that is what is called Libermans Nitroso reaction. So this is fifth one. Okay, the reaction name is Libermans Nitroso reaction. Libermans Nitroso reaction. So what is Libermans Nitroso reaction? Look at here, when phenol is treated with sodium nitrite and concentrated H2SO4. What is sodium nitrite? NaNO2. Sodium nitrite. NaNO2. Sodium nitrite, not nitrate. This is NaNO2. Sodium nitrite. And concentrated H2SO4 will develop a deep blue or green color. Okay, will develop a deep blue or green color, which will turn red on dilution with water. Okay. Now on basification with aqueous NaOH will regain the blue or green color. Okay, this is what is happening in Libermans Nitroso reaction. So we will go through the chemistry of this reaction, but first you look at here what is happening during Libermans Nitroso reaction. Actually, Libermans Nitroso reaction is a test to distinguish between alcohol and phenol. We know that alcohol and phenol are both are acidic in nature. Then how will you distinguish between alcohol and phenol? Okay, Libermans Nitroso reaction. So what is happening in Libermans Nitroso reaction? When phenol is treated with the sodium nitrite and concentrated H2SO4. When phenol is treated with the sodium nitrite and concentrated H2SO4 will develop deep blue or green color. First it will change into deep blue or green color, which will turn to red. Okay, that deep blue or green color will turn to red. When it will turn to red? On dilution with water. When you add water to this deep blue or green color solution, its color will be changed to red. Okay, now you can see that that red coloration will go back to the original blue or green color on acidic or basification with the NaOH. To that red colored solution, if we add NaOH solution, what will happen? It will go back to the starting blue or green color. This is a color change happening in Libermans Nitroso reaction. Now let us go through the chemistry of this Libermans Nitroso reaction. So keep it in mind, what is the first step? Reaction of phenol with sodium nitrite and concentrated H2SO4. That is what is happening in the first step. Okay. So phenol is treated with, look at here how I am writing all this structure. Okay, here you can see that this is our phenol. Okay, phenol is treated with sodium nitrite NaNO2 and concentrated H2SO4. This you know what is happening. What is this one? When it's a mixture of NaNO2 and concentrated H2SO4. This is what is known as, this one is known as, it is nitrous acid, nitrous acid, what is the formula? HNO2, actually this is HNO2, nitrous acid, or nitrous acid can be written as OHNO, okay, OHNO, okay, once again, this mixture of NaNO2 and concentrated H2SO4, NaNO2 and concentrated HCl, both can be used. Okay, what will form? It will change into nitrous acid. What is the formula of nitrous acid? HNO2. Actually, nitrous acid is only this one. NaNO2 and concentrated H2SO4 is nitrous acid. This nitrous acid can be written as, how we can written as OHNO. OHNO, correct? HNO2, correct? OHNO. HNO2 can be written as OHNO. So look at here, HNO2, HNO2. Okay, this is nitrous acid. So NaNO2 and H2SO4. From NaNO2 and concentrated H2SO4, what will be generated? Nitrous acid. This is nitrous acid. Now what is happening? Look at here. Okay, I am writing the same structure once again for better understanding. Okay, here it is. Here it is our phenol, OH, and of course here is a hydrogen atom. Okay, here is a hydrogen atom. Now I am writing our nitrous acid. Nitrous acid can be written as OH, NO, OH, NO. So you can see that what will be eliminated? This H2O will be eliminated. So what will eliminated? Minus H2O. Okay, minus H2O. And what we get? We get a structure like this. Okay, here it is. Here it is OH. Here it is OH. And here you are, what you are getting? NO means N double bond O. First you are getting this one. Okay, look at here, phenol. And from NaNO2 and concentrated H2SO4, nitrous acid, this is nitrous acid. Nitrous acid will be generated, this nitrous acid. So here is a hydrogen atom and OH, H2O will be eliminated. And what will happen? This NO will join at this position. You are getting a structure like this. Now in the next step, you can see that this OH means what is that? OH. Okay, what is happening here? You can see that as I told you, phenol, this OH side, this is acidic in nature. That means it can donate H plus ion. It can produce H plus ion, or you can look at here, this bond will be shifted to here. So what is removed from here? H plus is out. H plus is out. Look at here, this is a resonance structure. This will be shifted to here. So here it will become a double bond. That time this will be shifted to here. So here it will become a double bond. That time what will happen? This bond will be shifted to here. Okay, then here it will become a double bond. Then what time? This bond is shifting to oxygen. That means oxygen is getting a pair of electron and a negative charge. So what is getting? So you can see that here H plus is produced, and what we get? Look at here. Okay, here it is like this, and what is happening here? Here it will become a double bond, and since the bond is shifting to here, it will become a double bond, and this bond is of course there only, and since the bond is shifting to here, what will happen? Here it will become double bond N, and what is happening here? Here is okay, here look at it here. Okay, this bond is shifting to here, so double bond N, and this bond is moving to oxygen. That means here it will become a pair of electron and negative charge. Okay, here it is like this. Clear? Now in the next step, what is happening? This O is having a negative charge. This O will abstract this proton. Okay, this will take this proton. Okay. And see, look at it here. Okay, then what we get? We get a structure like this. Okay, here it is. Okay, here it is double bond O, and here you are getting double bond here. Here it is double bond En, and this H plus. First, in the first step, this H plus is removed from this OH. H plus is removed. Okay, H plus is removed. Okay. That means minus H plus. Okay, this H plus is out, that is why minus H plus. And in the second step, this H plus, that means you can write it as plus H plus. Here it is plus H plus, that because that H plus, this removed H plus is taken by this oxygen, and here what you will get? O, and what single bond O H. This H plus is taken by this oxygen. So in the first step, H plus is removed. That H plus is taken by OH. So you are getting a compound like this. This is known as quinone oxide. What is that? quinone oxide. Quinone oxide. I think up to this it is clear to you. Now we are continuing. This quinone oxide, okay, this is quinone oxide. Okay, this quinone oxide will react with another molecule of phenol. Okay, another molecule of phenol. So look at it here. This quinone oxide is reacting with another molecule of phenol. I am writing phenol. Okay, okay. Here is a hydrogen. This is a second molecule of phenol. Okay, another molecule of phenol. Okay, phenol. Then I am writing this quinone oxide. This quinone oxide. See, in reverse direction I am writing quinone oxide. That means here it is, okay, and I am writing this part here, double bond N, OH, okay, NOH, okay, phenol, another molecule of phenol is reacting with quinone oxide. Here is double bond, and of course here is O. Okay, just reverse I have written like this. Now what will happen? You can see that H from phenol and OH from quinone oxide will be eliminated. That means minus H2O will be eliminated, and what we get? We get a structure like this. Okay, okay. Look at it here. Here it is OH. Here it is OH, and here it is. This bond is joining with N. Then what is that? Double bond. Then our ring. Okay, okay, here it is, okay, double bond O. You are getting a structure like this. Okay, I think it is clear to you. Look at it here. H2 is eliminated. Then what is that? OS, the bond is shifting to here, and this resonance is happening. And finally, the oxygen is getting a negative charge. Now this oxygen will take this removed H plus and it will change into quinone oxide. That quinone oxide will react to one more molecule of phenol, and you will get a structure like this. And we are continuing. In the next step, okay, this will react with, immediately will react with H2SO4 present in the mixture. H2SO4 present in the mixture. So we are starting mixture is NaNO2 and H2SO4 is there. So therefore what will happen? This immediately will react with H2SO4. H2SO4 means it's a dibasic acid. It can produce H plus and HSO4 minus. It can dissociate into H plus and HSO4 minus, that you know. Okay, then what will happen? You can see that when it is reacting with H2SO4, H2SO4 can will be in the form. It can be dissociated in the form of H plus and HSO4 minus. HSO, this is present in the solution. This H plus from H2SO4 will be taken by this oxygen. Okay, look at here. I am writing the structure. Okay, here it is OH. Okay, and here it is our N, double bond N, then next ring. Okay, here is double bond, here is double bond, oxygen. Oxygen, look at here, oxygen is having lone pair electron. This lone pair electron will abstract H plus from H2SO4, Okay, then what we get? Okay, we get a structure like this. Okay, here it is OH, and here it is N, double bond N, and our ring is here. Okay, double bond N. Okay, N, double bond, then ring is here. Okay, here it is like this, and here you can see that double bond, this double bond. Oxygen, lone pair of electron is abstracting this H plus, so it will change into OH, and oxygen is getting a positive charge. Okay, okay, and okay, and here what is remaining? Lone pair is taking H plus, and since this lone pair is making a bond with H plus, oxygen is getting a positive charge. And what is outside? HSO4 minus. HSO4 minus is outside. Okay. Okay. This way it will change. It will change into a salt. Okay. That means this is known as indophenol hydrogen sulfate. Indophenol hydrogen sulfate. Indophenol hydrogen sulfate. This is responsible for the blue or green color. Okay. Due to the formation of this indophenol hydrogen sulfate, first we are getting the blue color or green color. Okay. So keep it in mind. This is responsible for the first blue or green color. Okay. Look at here. This is our this compound is reacting with H2SO4. H2SO4 can generate H plus and HSO4 minus. H plus will be taken by this oxygen atom, so it will change into OH with a positive charge. And what is remaining? HSO4 minus. HSO4 minus. Okay, so this salt, the entire salt is known as indophenol hydrogen sulfate. Okay, this is responsible for the blue or green color. Now in the next step, what is happening? What is happening? We are adding excess of water that we have written. That blue or green color on dilution with water will change into red color. So here we are adding water, H2O, excess of water we are adding. So what will happen? This H2O, that means lone pair electron present on this oxygen will take back this H plus from oxygen. Will take back that H plus from oxygen, or what we can write. Then what we get? We get a structure like this. Okay, here it is OH. Okay, here it is OH, and here it is N double bond ring. Okay, ring. Okay, here it is what is that double bond? Here it is O. Here it is O, and what is removed? This H. The water is removing this H again from here. Then it will change back to this compound. Okay, this structure, and we are getting this structure. We are getting this structure, and what is that? This structure is known as indophenol. Indophenol. This is responsible for the red color. Indophenol is responsible for the red color. So look at here. There is you are getting the same compound here also, but there is no possibility of forming a red color because this compound here immediately is reacting with H2SO4. And there is no independent formation of what is that here this compound here, indophenol. Okay, because this is forming, immediately it will change into H2SO4 and immediately it will change into indophenol hydrogen sulfate. Okay, that is blue color. Now this indophenol hydrogen sulfate, when you add more amount of water, excess of water, what will happen? This protonated oxygen will undergo deprotonation. This H plus is again removed, and what we get? We get this compound. Okay, now you can, if you want, you can write, since this H plus is removed from here, this H plus and HSO4 will again join together. Maybe you can written as H2SO4 minus H2SO4. This H2SO4 again removed. Okay, that means this H plus is removed by excess of water. That H plus is there and HSO4 minus is also there. You can write it as a minus H2SO4. Okay, minus H2SO4, that way also you can write. But actually what is happening? H2O is removing this H plus and it will change into H3O plus, and HSO4 minus is okay. Okay, anyway you can write it as for simple way to remember, this H plus is removed, then H plus is joining with the HSO4 minus, and what is eliminated? Again eliminated, minus H2SO4 is eliminated, and you get indophenol. This is red color. Now what is the last step? This indophenol, that means red colored compound on basification with NaOH. Aqueous NaOH, what do we get? We get back the blue or green color. The reason is that when it is reacting with NaOH, this is here you can see that there is OH part. Okay, like our phenol, OH part is here. This H will be replaced by Na, that means sodium salt. We get sodium salt of indophenol. That means what is the structure of that one? Okay, here it is ONA. Again, like reaction of phenol with NaOH, what will form? Salt and water. H2O will be eliminated, minus H2O. OH and H is eliminated. This Na will come to oxygen, ONA, and the rest is as it is N, double bond ring. Here it is double bond, here also double bond, here is double bond. What is this one? Sodium salt of indophenol. Again, this is blue or green color, blue color. Okay. This is the entire chemistry of Libermans Nitroso reaction. Hope you can you could follow this entire mechanism or the reactions of happening in Libermans Nitroso reaction. And thank you.